if I want to provide my new data to the model, so it can use that to generate new content. It's called a context window training. We create something called as RAGs. So I was digging into what can Flink do to really take this to the next level from stream processing is what was intriguing me. And I worked with some of our team members who have been working with our customers, as well as I am sure there are other options than Flink, but why Apache Flink? What makes Apache Flink?
Yeah. So there are 4 things that we'll cover that we think are super important. And this is sort of the decision we took when we first thought about building a managed service around open source Apache Flink. So in this case, this is something that you see customers do often when they want to extract information from their streaming data. So in this case, we've shown very simple ones, like in a window, a 1-minute window, what's the total count of the number of streaming records that you see, right?
Yep.
Or you can do a custom aggregation. You can do a sum. You can do any sort of different aggregation.
Good afternoon, good morning, and welcome to the Future of Data with Real-Time Analytics Revolution on AWS. We are excited to have Deepthi Mohan with us today, who's a Principal Product Manager for Amazon Managed Flink, and Bal Harar, who is our Senior Principal Consultant at Mactores, who will lead us through a discussion and try to answer any of your questions that you might have by leveraging the Q&A icon you'll notice below. In addition, we have a Flink webinar poll that's up, and we encourage you to take that as we go along. So Bal, over to you.
Hey, thank you, Dan. Welcome to today's panel discussion. Today, we are going to discuss about revolution in real-time analytics. We'll be covering some interesting topics about what is real-time analytics. I am joined by my co-host Deepthi, who is a product manager at Amazon Flink. We will be discussing deep into various architectural patterns, customer case studies, also bring a couple of recommendations about how we can see data, real-time data processing in various different customer use cases. And the most important topic of today's time is about GenAI. How can we use time analytics with GenAI? So with that, I would like to ask Deepthi to start with her introduction, and then we can start our panel discussion. So hi, Deepthi, thank you very much for joining. If you don't mind, if you can just give brief background from.
Thanks, Bal. It's my pleasure to be here today. Hey, everybody, my name is Deepthi Mohan. I'm a Principal Product Manager at AWS. I work on the Amazon Managed Service for Apache Flink. I've been with AWS for the last 7 years, and I worked on this product for 4.5 years now.
Thank you very much for joining us and having, helping us understand data streaming world better. So with that, I would like to, really hone on to what is data streaming. What does data streaming mean to AWS, and what does data streaming mean in general in the industry?
Sure. So I'd like to start off with the very basic of a stream processing pipeline. And what we have here on this slide really shows a common streaming data architecture. As you can see, it consists of a set of 5 steps. And I'm going to go through each of these steps so that we all have a baseline. Then we can start the discussion from there. And this is sort of important because we're going to keep referencing this base architecture multiple times through the webinar today. So
Okay.
first, I'd like to talk about the data sources. This is, any kind of device or an application where data is generated in real time. As an example, you could have customers writing from a client directly to a Kafka cluster, or you could have an IoT producer. You could have, the AWS SDKs, the AWS mobile SDKs, all sorts of clickstream products, application logs. So it can be a variety of sources. So most of the data here is coming in at high velocity, volume, variety, the 4 V's of data. So that's about the data source. The second step is stream ingestion. So this is an optional abstraction layer. So as you can imagine, you might have data coming in from tens of thousands of sources. This layer is optional, so you may not find it in all architectures, but you find it in most architectures where you have a place where you want to filter out, let's say, a bad actor. Let's say you have tens of IoT devices, one of them is failing, and you don't want that data to come through. This is a place where you would identify that bad actor and you can ignore that particular IoT device. Then you have what I call the heart of the entire pipeline, which is streaming storage. The advantage of streaming storage really is that it's decoupling your sources from your destination. So it's decoupling your consumers from the producers, right? So the producers are sending data at a very high throughput. And what the streaming storage does is that it helps store this data efficiently. So it can be processed by one or more consumers, and you can reference the data for a longer period of time. So this data is stored probably for a few hours, a few days, and sometimes it's also stored indefinitely.
Okay.
Okay. And then we'll move to what I think is the most exciting piece of this entire pipeline, and it's going to be the focus of today's talk, which is stream processing. So stream processing really helps you understand or make sense of all this data that you've collected and stored in streaming storage. So you can do anything from stream ETL, so extract, transform, and load to a different destination. You could do things like real-time analytics, and a lot of today's talk covers some of that as well. And you can have different types of stream processing. What I mean by that is you can have stateful stream processing or stateless stream processing. Let me give you an example. If you have, let's say, a temperature sensor, and you're converting the data that you get from degrees Fahrenheit to degrees Celsius, every transformation is the exact same formula. You don't necessarily need to store anything in memory to apply this formula for every data record that comes through. That is stateless processing. And there is stateful processing, wherein you have to keep some data in memory. Let's take the same temperature example, right? You have a sensor that's sending you temperature data. Now you want to find the average of that temperature sensor over every 10 minutes. For that 10 minutes, you need to store all the records that come through and then calculate the average on them. That is stateful processing.
Yep.
Okay. Any questions about that?
Yeah, so in general, so let's take an example of, so this is a great example for a temperature use case, largely an IoT use case I would keep. What about if we apply similar kind of examples in finance, right? So in what kind of examples we can think about in finance? What is stateless and what would be stateful?
Let me give you a stateless example first. So let's say you have stock ticker data. You have it coming from a different index, right? And you want to convert that to a USD value.
Correct.
For
Say
every,
maybe yen to USD. Yeah.
Yes. So the conversion is the exact same regardless of which piece of data or which stock ticker you are thinking about. So that is stateless. But if you want to think about aggregating that data over a day, let's say I want to calculate the final value.
Overall trend of the day is up or down. So if you want to find
Yes.
mean, if you want to compare it with the mean of the day, that would be a stateful. Great.
Exactly. Yeah.
So in a nutshell, a stateful is generally when you are aggregating data over a time period, or we can call it as a window, and then you are applying a function over that window and calculating in that window is mostly state. And stateless is where you are taking the data and converting into formats or converting, applying some kind of a function irrespective of the time window. So that's the real difference between stateful and stateless, right? If I can summarize it properly. Okay, good.
That's right. And then finally, in this whole pipeline, you have the destination. And typically, you send the data to some sort of data at rest. So you would probably send it to a data lake or a data warehouse or a database. Now, as I mentioned earlier, this is just the basic structure of a stream processing pipeline. You can have, multiple stream processing from the same streaming storage. You could have multiple sources writing the same stream storage. You could have data being sent to multiple destinations. You could also have chaining of these. But what we have here is the absolute basic stream processing architecture.
Fantastic. So this is great because there are so many things which we can do with streaming or non-streaming data. A batch data can also be treated as streaming to process the data faster. So this begs to a question, takes to a question where what kind of technology can be used to process this, right? So what is going on in the open source community as well as what does Amazon has to offer to really process this streaming data?
Yeah. So we can talk about both the open source options as well as the not the Amazon specific options. But today, because we're talking about stream processing, I'd like to cover a little bit about Apache Flink. And this is primarily what we are going to focus on in today's talk for the stream processing side of things. So Apache Flink is an open source framework and engine for processing data streams. And they consider data streams to be both bounded and unbounded. So referencing what you just said earlier, you can use it for both batch as well as stream processing.
Correct.
Okay. It covers three main use cases, and we'll go into those use cases, later when we discuss the different types of major use case categories we have, and we go into the customer examples as well. But really, we talk about streaming ETL, so extracting, transforming, and loading. You have real-time analytics, so how you react to certain incidents that happen in real time so that you can make business decisions faster. Okay. And finally, you have event-driven applications. So based on some event, you are taking some action downstream. There's a couple of other use cases as well that we'll go through as we go to those slides.
Just to hold on to that event-driven application, so does that mean Flink can say aggregate? For example, in previously we were discussing we can have a stateful aggregation in stream processing. So Flink can aggregate on a data and raise an alarm, and then can trigger something like a Lambda function or an application API to actually work on that alarm in some way. So is that also possible in an event-driven application? Great,
yes.
Fantastic.
So you can call something downstream to alert either humans or a different system to take a look or to react to an event that has taken place in real time.
I am sure there are other options than Flink, but why Apache Flink? What makes Apache Flink?
So there are four things that we'll cover that we think are super important. And this is sort of the decision we took when we first thought about building a managed service around open source Apache Flink, right? The first is the APIs of Flink themselves. Super powerful APIs. They are very easy to use and flexible, and they are layered. And why this is important is depending on how comfortable you are with certain languages or how deep you want to go into the processes of the exact state and time that you have for your application, you can go as deep as you want to in the layer. So you have the process functions API, which involves writing a lot of code, but also gives you a lot of control. Whereas when you move up the stack, you have the data stream API, which is a bit of a mix. So you can write, code in Java, Python, Scala. You have some control over time and state. And then if you want to go even higher up the stack, you have the SQL APIs, which almost any developer, many non-developers also can write SQL. But imagine you can write SQL against streaming data, just like you would against your batch data source. So it's the flexibility between expressiveness and how much control you have that really makes Flink special. And the one other thing is, within the same application, you can use any of these APIs, and you can, fit a SQL statement within your data stream API, or you can reference a process function within a table API call. So that flexibility is what makes Flink super powerful. So that's one. Any questions around that I can help answer?
Yeah, I just want to double click on that SQL API, right? So many of the data engineers or people who are well aware of programming are comfortable working with these technologies. And but we hear a lot of business teams or business analysts who are very good in SQL would also like to be, involved in real-time streaming to a capacity where they can query the data in the real-time stream, so they can help their data engineers to implement solutions better, right? Most of the data analysts work on the real-time stream data and then want to, guide the engineers how they want that data to be processed. So is that also available in Flink, where a normal common business analyst can write SQL queries and query data?
Yeah, that's exactly what the SQL API is built for. So here you
Okay,
have the SQL and the table API, right? The
correct.
SQL API is purely just SQL. So you write, it's very like ANSI SQL compliant, right? So it's very familiar for those that may not be hardcore Java or Python or Scala developers. There's also the table API, which is, you could think of it as a wrapper around SQL. So if you are comfortable writing Python, that's the API you would use. So it caters to different types of developers and non-developers, and that's what
Perfect.
makes the APIs of Flink so powerful.
Fantastic. And that's why probably you chose Flink to be managed, right?
Exactly.
Great. So let us see a little bit more about what does managed mean, right? So I'm very curious now, how can a a company or a customer take Flink, all these features of Flink, and most of the customers we made don't want to manage infrastructure, don't want to manage the installation and security around it. So what does fully managed Flink mean in the customer context? So if you can just help me understand, if I am talking to a customer, instead of deploying Flink in an EC2 instance, what would fully managed Flink offer?
Sure. So as you can imagine, Flink, because it helps with all these processing guarantees, manages both the state of the stream as well as the time concepts that are very important in stream processing. There's a lot that goes around building a Flink cluster. So what really a managed service does, in our case, the managed service for Apache Flink does is anything that is the infrastructure. So all the way from your instances, your storage, your Flink cluster configuration, all of that is managed by the service. And all the customers need to do is to focus on their application code. So they'll only think about the Flink APIs that we spoke about and how to use those to realize their application logic in a language of their choice. They don't have to worry about, oh, which instance type should I use, how much I should think about security, multi-AZ deployments, failure modes. All of that is managed by us. So
Great.
really, all they're thinking about is the highest layer, which is what's the application logic and how do I solve my business case. And everything else is managed by the service.
Fantastic. And then some of our customers generally have questions around the optimization, right? So is there an area for optimizing Flink in some cases where you want to set some parameters for your Flink jobs? What kind of customization is available in fully managed Flink from the application code perspective?
So what customers really need to do is write their application code. So there are, we talked about the two different types of APIs. So that also lends itself to two different types of interactions that customers can have with the service, right? So the first one and the more common one is customers write their code. If it's in Java, they build a jar. If it's in Python, they build an executable, and they submit that executable over to the service. Along with that, you can also submit application configuration. So that's where you can tweak different things on your application depending on, let's say, how much you want to, or if you want to turn on auto scaling, if you don't want to turn on auto scaling, how much you want to provision your first application for, like if it's, how much parallelism do you want for your application? That sort of thing is also provided as a configuration to the service, and the service will respect that configuration, but take your code and run it continuously.
So it's basically automating most of the scalability and configuration aspect just by configuring it inside a file rather than writing a lot of scripts, writing all kinds of automations or writing all kinds of monitoring services for
Yes,
managing Flink in EC2, which actually takes off about more than 90% of Flink
absolutely.
management load off the shelf, right? It doesn't, nobody has to really work and keep on monitoring everything in the Flink. What you might have to end up looking at is the job itself. If your job is generating right kind of data, is processing the data properly, but you
Yep.
really don't have to look into any management aspect of the job.
Yes.
That's
And I do
great.
want to touch upon one thing that you said, and it's the monitoring aspect. Because the managed service already integrates with CloudWatch,
Mhm.
you can emit all of the uh, automatically emit all of the metrics and logs directly to CloudWatch.
Oh,
Both the
that's
f-
fantastic.
yeah, both the Flink logs as well as the application logs go into CloudWatch logs. So it's super easy and familiar for customers that use AWS to really understand where in their application they should be looking at in case they want to debug something. So that's
Yes.
one specific area. And there's also a Flink dashboard, which is provided by the open source Flink technology that we give access to
Mhm.
on the console. And you can also just figure out the URL for your application. And you'll be able to see, like you said, the Flink job and the Flink job performance. So you really care only about what you wrote, the
Yeah,
code that you wrote as a customer, rather than the nitty-gritties of the infrastructure, which you don't have to worry about.
great. So that UI generally helps us understand the latencies from the source to destination, back pressures, and all of that. That's a great UI to debug any kind of real-time issues, right?
Yeah.
Yeah, that's fantastic. So uh, we briefly covered about what does managing Flink look like, and
Mm-hmm.
how do you cover manage all those aspects in the managed Flink service offering.
Mm-hmm.
But many customers come back to us and say, okay, this is a great new service. I understand. I would be very much interested to use this, but where does it fit in the multi-layered stack of these
Yes.
modern data platforms, right?
Yeah.
So that's a very important question. I have data sources coming in. I have data lake. I have data quality jobs running. There are so many components to these modern data platforms.
Yes.
Where does managed Flink really fit in?
Yeah. So this goes back to the very first slide that we spent some time on today, understanding the stream pipeline architecture. And this is a different view of the exact same pipeline, right? So you have your data sources, which can be IoT sensors. You have two options that Amazon provides for streaming, ingestion, and storage. One of them is Amazon Kinesis Data Streams. It's a AWS-built, massively scalable streaming storage service. And then you have the open source option, which is managed streaming for Apache Kafka, which, similar to the Flink discussion that we're currently having, manages a lot of the infrastructure and just cluster management and all of that stuff for you. So all you need to think about is the Kafka application itself and what you need to do. Then you have the processing piece, which is what we were talking about with Flink today. That's where it fits. So it can read from Kinesis data streams or Kafka or any variety of other batch and streaming sources and send the data after processing to a variety of destinations. The most common destination is actually S3 because you're sending data from some kind of streaming source to a place at rest. So that's typically S3, but it could be any sort of database, data warehouse. It could also be another Kinesis data stream or Apache Kafka topic in case you want to have multiple, like a chained sort of processing pipeline. And there's also a delivery service, Amazon Data Firehose, which
Mhm.
takes data, does extremely minimal processing from Kinesis data streams and managed streaming for Apache Kafka and sends it to a variety of destinations. So the difference between these two, and I get a lot of questions around that, so I will preempt that question. If you want to do any sort of processing, the windowing concepts that we spoke about, if you want to
Mhm.
do aggregations, if you want to do transformations, use managed service for Apache Flink. If you just want to deliver the data from source to destination, use Amazon Data Firehose.
Great. So there are a lot of use cases in our customers where they would like to take the real-time streaming data and then enrich it, right? So for an instance, you have web click stream data,
Yes.
but then I want to, give some custom offers to people who are coming on my website. May not be real time, but at least in near real time.
Mhm.
So, uh, what if I stream my web analytics, which gives me some demographic information?
Mhm.
Uh, it might not identify the customer, but for that demographic information, I want to enrich that streaming data
Yeah.
with some kind of offers, as well as how long that person is on my website, what all different content is looking. Based on that, I want to go do some kind of processing. Is the managed Flink the right offer for that? Is the solution for that? Can I?
Absolutely. And that's a superb question because almost every use case we think about really involves joining data from multiple sources, right? And this can be multiple streaming sources, a batch source with a bunch of streaming sources. So that's where you would use managed service for Apache Flink because you could join the data that's coming in from Kafka with some file in S3, right? Going back to your demographic example, let's say I'm getting some data about a bunch of customers that's in streaming fashion, but I want to go reference some demographic specific uh, file sitting in S3 somewhere
Yeah,
to understand what would be the right combination of recommendations to give these customers in real time, right?
correct.
So
Yes,
you could join both of these data sources and infer and send back to whatever application that you have the
yeah,
information that you currently have. So this could be something like a machine learning application, right?
yeah,
So
yes.
you are trying to figure out the best possible recommendation in real time for a customer that's clicking through a website. That involves joining multiple data sources in real time, and that's what you can do with managed service Apache Flink.
And then your example, like writing back to Kafka, so if application can read from Kafka
Mhm.
as well. So one side Flink can just keep on processing the data and write back to Kafka, so an application can read. At the same time, it can go and write to data warehouses and data lakes. Great.
Absolutely.
So uh, what are the core differentiators of managed Flink in for a customer who is super excited about taking this benefit of taking the real-time streams?
Sure. So we look at the core differentiators across three main pillars. The ones that you see here, there's ease of use, there's Flink out of the box, and then there is the core ones that you expect from any AWS service: availability, security, and durability, right? So as far as ease of use is concerned, we have the fully managed and serverless offering. There's no infrastructure setup, so all you worry about is
Oh,
your own application code. We also manage the application lifecycle, right? And state management, which is very unique to Flink because you have really two concepts. You have the application and you have the state, right?
yeah.
So the application, you have APIs that we provide you for create application, start application, describe, update. It's super simple. And then you have the state management because we have two different concepts in Flink for really getting yourself out of any kind of failure. So there's checkpoints and save points, and we'll go into further detail
Yeah.
if you're interested. But the state management is also simplified such that you don't have to think about state as its own entity. We manage that for you. So you still have, create snapshot or create save point. And in case of checkpoints, which are automatically created, all you need to do is set how often do you want to take a checkpoint? So it's just a configuration. So you don't have to manage any of that yourself,
Great.
right? And the
So
most important thing is,
I
sorry,
would
Bal,
like
just
to
go.
oh no, sorry, I would like to double click on that. As you said, it's
Mhm,
very interesting. So
mhm,
for our audience, it would be very interesting to understand that since this is a real-time processor, right?
mhm.
Uh, it is not a database where we're storing anything, it's everything in memory.
Yep.
And if we are doing the as in our previous example, a stateful calculations on a window and calculating things, what if the infrastructure goes down, right? It is always
Yes.
possible.
Yes.
And then you might lose all the data. Do you
Yes.
reprocess everything from your stream, or how does that work? So if you can just
Yes.
help our audience understand what are the mechanisms to have the availability, kind of high availability in the code?
Yes. So Flink offers two different ways to manage your state, right? And that's the key to keeping your application running with exactly one's processing semantics, right? And that's the crux of using Flink versus, let's say, building your own thing for stream processing, because you get this exactly one's processing guarantee out of the box. And that's through two different mechanisms. One is called checkpoints. So when an application is running, the running application state is automatically backed up for you. Okay. It goes into storage at a particular cadence that you can set. Typically, customers checkpoint every minute or every hour, some sort of regular cadence. And in the case of managed service or Apache Flink, we have the best defaults that you can imagine for a particular application. So there is minimal impact in terms of, let's say, under the covers, one of the instances goes down, right? For a real-time processing application, you don't want that to affect your processing. So it looks at the last good checkpoint and starts reprocessing from there. And it still continues to maintain the exactly once processing semantics because it knows, the application knows that this is the last checkpoint and what has been processed so far. So there's no question of going back, reprocessing the entire stream, because by that time you might not even have the data stored in your streaming storage by the time your processing application goes down, right? So that's one. And then this is only when the application is running, right? Checkpoints are only when the application is running. But there's another concept called save points. So this is, you can create a save point. We also call it a snapshot that creates the entire application is replicated and stored in durable storage. So it's a previous point in time snapshot. Okay, so it includes the sources, the destinations, as well as the application state. So this is useful in case of you want to update your application with some new code, let's say, right? So you take a snapshot and you have the entire application stored in its entirety. Now the new code, you have updated your application logic. You are still continuing to process from the point that you took the snapshot. This also helps in scaling or, any other kind of code or configuration update where you can still continue processing from that point. Now, what managed service for Apache Flink does is we automatically take a snapshot or a save point for you every time we scale the application on your behalf, or you scale the application, or you update your application. So that's the managed aspect of the state as well. So you don't have to necessarily go and do this yourself. We do it for you every time. So all you think about is, oh, I just need to update my application right now. So you go and update the application. Under the covers, we take a snapshot for you so that we still continue to maintain exactly one's processing.
And you take care of the storage and everything.
Yes,
So there is no storage configuration needed.
No.
That would be a great service to have, because managing Flink snapshots and the corruption from it and the restoring from it is a major challenge when you're self-managing it, for sure.
Yes.
That's great. So so that's why you call it Flink out of the box, which is a great functionality to have.
And
So good.
Yeah, and there was one more thing I wanted to cover, which is the patching aspect, right? So
Yes.
under the covers, we are running ultimately on instances, right?
Yeah.
And there is a lot of work that goes into patching your infrastructure without affecting your real-time processing.
Correct.
Right? Because your applications need to run 24/7 and you don't want to see gaps in your data. If it's, let's say it's a real-time dashboard, I don't want to see gaps in my real-time dashboard because I'm patching, right? So that's another value add that's provided by the managed service for Apache Flink, where it's completely invisible to you.
Green and blue deployments like we do generally on self-managed, that you have one which is getting patched, another which is processing the data, and then you flip between them. So I don't have to waste a lot of money in creating parallel infrastructures while the patching is going on.
Correct. And we manage that for you as a managed service.
Fantastic. That makes so much sense. Means ideally nobody should be managing their Flink clusters on them by themselves.
Yep.
Patching can be done seamlessly without affecting the end user performance. I know we spoke a lot about, a lot about Flink and what does Flink has to offer. But I would also like to understand the ecosystem, right? What are the ecosystem does a managed Flink provide? Because as you know, most of the data analytics products is all about ecosystems, right?
Mhm.
Most of the successful products or successful open source projects like Apache Spark, Kafka, and you name it, right? So has been successful, like Hive, have been successful because of the ecosystems built around them. That is what actually creates the that open source community very vibrant. So can
Yes.
you dig a little bit deeper on what are the Flink ecosystem look like? What does Amazon managed services to offer?
Yes. For this, I'd like to talk a little bit about the Flink connectors.
Mm-hmm.
So the Flink connectors, there are seamless integrations with any sort of data source to any sort of destination that you can imagine. We have a few listed here, right? But there's also AWS specific integrations, and that's the area that we contribute to open source as well, which is primarily Kinesis data streams. We make changes to the Kafka connectors, the Amazon Data Firehose connectors, the OpenSearch connectors, right? So all of these are super important to our customers, and they are also the most widely used, as you can imagine.
Mm-hmm.
But overall, there are hundreds of Flink connectors. It's very easy to build a Flink connector. In fact, um, with the launch of the async sync framework, you can build a new sync connector in less than 20 minutes.
Yeah.
Right? So it's a super powerful framework where you can really build connector to any sort of AWS service or other non-AWS services as well, really, really quickly. And that, I think, is one of the most powerful things that the community has come together to build and really makes Flink powerful.
And then we can use this connector with managed Flink as well.
Absolutely. You can use all Flink connectors with managed Flink.
Fantastic. That is a music to a lot of data engineers' ears, because that's what is always challenging is to when we adopt a managed service, can I take an existing connector which works and use it rather than writing everything on my own?
Yeah.
That's great. So how does the pricing work? We may not go in depth of
Yeah.
pricing, but it's very interesting. All of our customers are very much interested in understanding, okay, I would love to do the data stream processing. If I put it on EC2, I can manage and control the cost by myself.
Mhm.
But then doing all of these great managed features, especially the patching one, and at the same time snapshot when there is an update going on, which are, I think, one of the most difficult things to do when you're self-managing it. So how does the pricing work at 10,000 feet? There might be other complications to it, but
Yeah.
at 10,000 feet, how does it work?
So we use this unit called a Kinesis Processing Unit. It's a KPU, which is one vCPU of compute and 4 gigs of memory. It has an associated 50 gigs of disk as well. So this is the unit that we meter and bill for. So if you're creating an application, you would think about, okay, how many KPUs do you think this would be? There's a bit of trial and error there because you will be able to optimize, let's say you start off with 8 KPUs. If you increase your parallelism and if you increase the number of task slots, so parallelism per KPU, you'll be able to get more throughput for example, for your IO-based applications with lower KPUs. So maybe you end up with 4 KPUs. So there is a ballpark that we say that 1 KPU is 1 megabyte per second of throughput. That's the ballpark. But in general, there's scope for a lot of optimization because depending on the type of application you have, you can get, hundreds of Mbps as well per KPU.
Okay. So it really depends if it's a stateful or stateless and how the code is written.
Yes,
And
how simple or complicated it is.
correct. Okay, good. So I think with the given URL, customers can find the pricing of KPUs and how their application might translate into the pricing
Yes.
themselves from here, right? Now, before we proceed, I want to just hold on to where does the Flink come from, right? Why did Flink where we would like to understand the brief history of
Sure.
taking Flink into consideration, right?
Yeah. So one thing I do want to call out is this service has been around for quite some time. We've supported Flink on AWS as a managed service since 2018. Okay. So the history is that we launched the first Kinesis data analytics for SQL service, which is not Flink based, in 2016. Okay. It was one of the first stream processing services out there.
Yep.
But then that
Remember
was
using
only
it.
SQL. Yeah. And that it was only based on SQL. It's very simple to get started, which was great. But customers quickly told us that SQL doesn't solve all of their use cases. So they wanted more flexibility and more depth in terms of, long running applications, right? So they wanted like a Java based or a Python based offering. And at that time, even at that time, Flink was already making extremely advanced processing capabilities, or showing all of those processing capabilities in 2018. So we picked to go with Apache Flink as a managed service. And then we continue to call it Kinesis Data Analytics because we only supported Kinesis data streams as a source at that time. So we're keeping all of the stream-based services under the Kinesis umbrella. But in 2019, we launched support for open source Kafka as a managed service, and that was outside the Kinesis brand, right? So customers were always really confused. Why does Kinesis Data Analytics work with Kafka? So it was a bit of an impedance mismatch in the naming. So in 2023, we renamed our service from Kinesis Data Analytics, this Flink part of it, from Kinesis Data Analytics for Apache Flink, to calling it what it really is, which is an Amazon managed service for Apache Flink.
Great. And that has solved a lot of mystery of different kinds of
Oh,
services which are offered to our customers as well.
for sure. Yes. And it's a very easy conversation to have now compared to, every time we have a Kafka customer asking us, oh, why does this work with Kinesis? We have to explain the whole story. So the renaming really solved the awareness problem.
Fantastic. So with this, Deepthi, I want to really hone on to what are the use cases, right? So we have talked a lot about what is Kinesis, what is Apache Flink, how managed Flink, what are the offering of managed Flink. We also talked about the stateful and stateless. We talked about how the managed Flink takes care of the snapshotting, upgrades, patching, and briefly discussed about pricing, which is, I think, is a cool model. Instead of thinking about in EC2 terms, you are creating a unit of compute, storage, and memory and charging for that, which is easier to think for a developer on how much real compute power, storage power, and memory power I need and scale in that mechanism. But with that, I want to really get into what are the which customers, for what use cases can they use that, right? So let's get into what does real-time data processing really mean from a use case perspective. Sure. And let's cover some architecture patterns.
Sure. So I'd like to talk about streaming ETL, which is delivering streaming data in seconds. That's what we call it here on the slide. But that's really the most common use case that any customer starts off with, right? So you have your stream data that's coming in. You want to transform it, aggregate it, or filter it, and you want to send it to a destination. The destination can be another streaming storage, like it could be a Kafka topic or a Kinesis data streams, but most often it's either S3, a database, or data warehouse. Okay, so that's the primary streaming extract transform load use case. Then you have the stateful event processing one, which is, you can think of it, an example would be like fraud detection or anomaly detection or rules-based alerting, right? And the third one would be responsive real-time analytics. So streaming ETL, I just said you're taking data from a streaming source. You could think of it as, let's say, CDC. Very common use case today, where you have...
Like using DBCM or say Amazon DMS to take the CDC and put it in Kafka.
Yes. So you can do, let's say, a window where you are deduping these records so that you only write to the data lake once.
Correct.
Right? So that would be a very simple streaming ETL example.
Great. So it's more like enrichment. So as we discussed about, I have a web
Sure.
traffic coming in, then for example, somehow through the web traffic, if I get the cookie information, I might get the customer information too.
Mhm.
And I can use my customers 360 database
Yes.
to do a CDC and also stream data about that customer in a Kafka, which I can and then provide a almost near real time inputs into what the web traffic look like in the data lake. Okay, great.
Yes.
So what does the analytics mean here? So what does data analysis
Yeah.
okay.
So in this case, this is something that you see customers do often when they want to extract information from their streaming data. So in this case, we've shown very simple ones like in a window, a 1-minute window, what's the total count of the number of streaming records that you see, right?
Yeah.
Or you can do a custom aggregation. You can do a sum. You can do any sort of different aggregation. This sort of pattern helps in, let's say, quality monitoring.
Yeah.
Right? Or you want to do ad hoc analysis of your streaming data. Let's say I'm a new developer who's coming in to check what my streaming data looks like so that I can write applications later. They would just query the data to understand the pattern or what really the different sources look like. As you join these sources, what does the data look like? So that kind of ad hoc analysis also forms part of the real-time data analytics umbrella of use cases.
So I have a question here. So we talk about a window, right? 1-minute window. What if I want to compare my data with the last 1 minute in the before, right? So
Yeah.
we can imagine this as a static window. I am looking at 1 minute in increments,
Yeah.
but I might want to see and compare it with the 1 minute before the 1 minute, right?
Yes.
So how do that work? So what are the different kinds of functionalities I can implement in data analysis?
Yeah. So you could, store, let's say, the average of 1 minute, right? And then you can also look at the next minute. And let's say you have the average of that. You can store both these in your application, in the application state to be specific. And then you'll be able to compare the two. And let's say you want to trigger off some sort of alarm if the average goes up by 5 points.
Yeah.
You can do that sort of triggering as well. But if you just want to maintain, some amount of state, to compare your current window to the previous window or the next window, sorry, you will be able to do that in the application state.
Okay, so this will be really useful in so many applications with healthcare data, financial data, as well as IoT applications. Fantastic.
Absolutely.
Let's talk about anomaly and fraud detection.
Yeah, and this is what we call stateful event processing, right? And you were talking about financial transactions. So this is really about, let's say, the example here is about credit card transactions. And you have a lot of transactions that you've been making, but all of a sudden there is one that is 100 times more than what you typically spend. And you would really want to know that in real time, especially if you are not the one that's actually spending it, but somebody has stolen your credit card data and is using it in a different city, as it has happened to me multiple times. You really want to understand that this is an anomaly. I typically spend less than $100 in Chicago every day, but today I've spent $5,000 in New York. That is an anomaly. And we have multiple types of anomaly detection that you can implement within Flink using Flink ML, which is the machine learning library for Flink. And you'd be able to detect anomalies as they happen. So you don't have to wait for the bank to come and tell you after a day or two that this has happened. You would be notified immediately through this sort of real-time fraud detection.
Great. On the topic of ML, I want to cover couple of discussions on GenAI, which is quite interesting, right?
Yes.
So technically, we see GenAI being used for personalization, and then create custom content. I would like to also, discuss a little bit about how does Flink really affect GenAI? Is there any use case for that? for that, I want to just dig deep into what do I mean, right? So in GenAI, RAGs have been taking, RAGs, which is retrieval augmented generation, which has, taken a world by storm. What it really does is it takes your data, which is very customer centric or use case centric, and creates the called as something called as vectors, uh, which essentially mean a data which can be understood by the model. It creates a vector, so you can tell that Gen AI model the some level of customization you need in your responses from it, right? Because a Gen AI model once trained doesn't is not constantly getting trained on new data. So if I want to provide my new data to the model, so it can use that to generate new content. It's called a context window training. We create something called as RAGs. So I was, digging into what can what can Flink do to really take this to the next level from stream processing is what was intriguing me. And I worked with some of our team members who have been working with our customers as well as experimenting a lot with Flink and GenAI. So this really hones on to taking the data from the data lake or from the different sources and analyzing the data in real time so you can provide updates to say user data's profile history. So for example, you have customers who are buying products and the value of that product is either increasing or the stock of that product is increasing or decreasing, and you want to real time process that how many customers have bought this particular item before, and if it's going lower in the stock, you can go and tell the customer that this is going low, we can offer you discounts, and generate some kind of an email or generate some kind of a chat response, or a notification, a custom notification for that user. But that is where you need stream processing, because as your inventory is changing, you want to process that. Other one is providing real-time data to embed that in your search outcomes, and then create some kind of content or some kind of text in your search content which refers to the real-time data which has been processed. So there are many different ways we can look into it. I want to just hold on to one use case, Deepthi, and I would like you to ask me questions or
Yep.
just let's brainstorm on this. Let's take an example of flights, right? So if you are Expedia, for example, this is not Expedia, by the way. If you are Expedia, how would you look at creating a bot, right? And this is a fictional example. Say you constantly get the flight updates, the bookings which are happening on your platform, and there is a large network of this flights and bookings and offers which keeps on happening in the rest of the world.
Mhm.
And then you're connected to this network which sends you real-time updates. And then you have set of your customers on your app or on your website maybe, who needs to buy tickets and would like to interact with a bot, right? To purchase tickets. That's always a challenge, that when I want to go and buy a flight ticket, I want a custom experience. Uh, my book, my bot needs to know yeah, the flights I generally fly in, if I already have some kind of mileage plan, if I have some preference of seats, some preference of pricing, my home base, and my regular fly base, right? So there is so much of customer loyalty and CRM data which needs to be part of this. But the most important is what is changing constantly is the new offers, the new pricing, the cancellations, and then the addition of new flights, which this is the real time data which keeps on changing. So what we found out was, in an example where one set of data is static, which is historical, and another set of data which is constantly evolving, we can actually take the evolving data and create a real-time embedding inside the something like Elasticsearch or OpenSearch, which can form as a vector DB, and take all the customer data to start recommending customers in real time, recommending them what are their options, what they can
Mhm.
do based on their previous history, also the changing, evolving landscape. of the new flights which are coming in. And definitely we can use Amazon Bedrock, which offers Claude, which offers so many different models today, LLM models which are pre-trained, and help us do a context window training, which essentially means you can create your custom vectors and rags in your open search service. For an example, many services supports vector DBs, but in our use case, we thought open search would be ideal uh, to train it and generate custom content for as a bot, custom content for your customers, right? So what I was trying to allude to here is there is a need not only to take your historical data
Yep.
and then use bots to answer them, but constantly changing, evolving stateful data, stateful streaming data, as we were discussing, a window-based data, right? So if the pricing of the flight is changing on an average by $2 or $5 every hour, you want to notify the customer that this is the flight which is getting full, which is getting booked, and the pricing is changing, etc. So that all contextual learning needs to be provided to the model every time somebody is submitting a question to it, right? And that is where we have seen Flink being, phenomenal at processing this data and helping the bots generate data, generate content based on the real-time data. What
Absolutely.
do you
Thanks
think
for
about
sharing
this?
that, Bag. And this is something that, has taken the world by storm pretty much. But what's
Yeah,
unique about this is typically we only think of the batch-based pre-trained models when you think about GenAI, right? But
correct.
what's really unique in this piece is the streaming aspect of it. So the real-time aspect of bringing in the most relevant recent information and joining that with your pre-existing data to make the customer experience more valuable.
Correct. Absolutely. So I know we are a little bit out of time for this webinar, but I would still like to, cover at least a couple of customer successes.
Yep.
So I heard a lot about NHL
Yes.
and how they have been, using machine learning in their real-time gaming.
Yep.
So I'm glad to see that they have used AWS services. So can you please help me understand what was NHL doing
Yeah.
with
So
Flink?
NHL, along with AWS, worked on this thing called Edge IQ. That really makes it an immersive experience for fans and spectators watching the sport, especially on television. When the puck is in play, based on the players that are facing off, it provides the probability of each player or which player will win the playoff, right? The face-off, sorry. So it really is showing you in real time, in near real time, exactly what's going to happen in the next couple of seconds, right? So it's really very interesting for spectators that are watching the sport, and this sort of experience is what really makes a difference when people are trying to experience the game even when they're not there. And this entire solution was built with a combination of all the streaming services that we covered today. Both Amazon Managed Service, or Apache Flink, and Kinesis data streams played a critical role in the architecture of building this solution.
Great. And I also have a couple of case studies which I would like to cover. So one is with Poshmark. As you know, Poshmark is a I'm sure a lot of people on the call knows Poshmark from it's an e-commerce website where largely 90% of women trade their fashion goods online, and the experience Poshmark wants to create is seamless experience of recommending the best deals which are coming in, what other people in their area wants to sell on their platform. So it's kind of an eBay, but very specialized for fashion products. And what they were challenged was to improve the customer experience and provide the revenue growth per customer transaction. So they were completely focused on how do we take this real-time data which we get from our web portals and then analyze that real time to provide customers a real time recommendation of in their areas as soon as the new listing comes in. If they did that particular listing is in their price range, is that something which they have put them in preference? And so they took all the data from every post their users creating on their website and stream it through Kafka so that it can be processed by Flink if it is a right fit for their customers, and then that would trigger notifications or emails for people who are engaged in the community of a particular brand. And that created also helped Poshmark increase their market share because it was clearly focusing and targeting on the needs of the customer and their preferences and giving them the best deals from different regions of US.
Right.
And
So
sorry,
we spoke about both the immersive experience with NHL,
Yep.
and here we're talking about tailoring the experience, how Poshmark tailored the experience around their customers to make it both great for their customers as well as themselves in terms of
perfect.
improving their KPIs.
Yeah, absolutely.
And I'd like to hear a little bit about an IoT use case, because we spoke about a lot of web and real-time analytics. So how about we switch to an IoT use case?
Yeah, absolutely. So this is HP, and I'm sure everybody knows HP, but we are specifically talking about the ink division. This is the division which manufactures cartridges. And one of the major challenge of uh, HP was to identify the 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 challenges in manufacturing, which happens across the world, across different manufacturing plants, and they wanted to really figure out areas of improvements in their manufacturing life cycle, right? And since they manufacture inks in different places with using different techniques, what does that mean is some cartridges gets produced, say, in Singapore, and then they get shipped to Malaysia to further process and finish the entire product. So they would like to calculate and understand the state of each of this unit of ink cartridge which has been manufactured, and also track it to make sure there is no pilferages, there is no loss of manufactured good, semi-manufactured good. So they were really interested in finding out a smart factory solution which processes data in real time and not in batch mode. This is where we help them connect all of their on-premise devices which are involved. As you might imagine, these are all standalone systems which are robotic in nature, which spits out a lot of real-time data, which is very valuable to provide the state of the manufactured product. And we are talking about millions of cartridges produced every week. So we are talking about a very large scale of information which needs to be processed in real time to make sure there is no anomaly, there is no pilferages, there is no loss of manufactured goods between between what is manufactured in one plant versus
Mhm.
another when it is getting shipped. So this is a multi-layered problem, of course. But what was very interesting is now we are taking the IoT data from these devices and comparing. So we actually implemented all three solutions. We had ETL because we had to take batch information from a database. Then we had windowing because we wanted to calculate the average cartridge life cycle and wanted to understand how many cartridges are processed in a window of time and compare to averages. And then we also had anomaly detection. If a particular cartridge leaves which has already been manufactured but was coming out for boxing, has not been detected in a day's time, then we have to raise an alarm that this range of cartridges or this particular set of cartridges were not even available for boxing, right? So there were all three use cases which we discussed previously were part of the solution, and this gave them very high amount of efficiency. They increased their efficiency by 40%, and improve their yield because they could detect the loss of cartridges and the loss of manufactured good in real time. So this was the IoT. This is a IoT plus business use case to not worry about scalability, at the same time could focus on the business problem than managing the infrastructure.
Absolutely. Yeah, that was a great example that covered all three major use cases
Yeah.
we discussed today.
Absolutely. A brief on Mactores before we leave. Mactores, we are focused on building data solutions, and we treat data as an asset, not as a product. So what does that really mean is we think about how to take data and use it, transform your businesses. We have been AWS partners since 2008, covering a lot of competencies across data analytics. We focus on data analytics, machine learning, and AI. We are exclusively known by our customers for having something called as migration accelerators. So we have built a lot of automation tools to adopt AWS services, namely EMR, Glue, Redshift, and streaming like MSK and Flink. So we have helped customers migrate MSK, adopt Flink in an accelerated way. And that is where Mactors is a unique position. We have a unique position in marketplace that we build automation tools which helps you adopt these technologies much faster. With this, I would like to thank Deepti and thank you everyone for joining this webinar. We look forward to work closely with you to understand your business use case and implement some of these cool solutions. Have a great day ahead.